Hey guys, welcome to Video Math Lessons. Tonight we're doing a rational review, Math 12. Hi, welcome to Video Math Lessons. Tonight we're doing a Math 12 pre-calculus. We're going to be talking about rationals and we're going to be reviewing all types of problems referring to them. So let's get started. So hopefully you download the PDF. If not, write this down please. So it says for f of x equals x squared plus 7x plus 10 over x squared plus 3x plus 2, find the following information. So what we have to do is, when I have my original problem, what I need to do is I need to factor the top and factor the bottom, because I need to see what all the pieces would be. So I'm just going to factor the top, factor the bottom, nice and easy. So the top I get is x plus 5, x plus 2. And the bottom I get is x plus 2, x plus 1. So what you need to know is what all the pieces stand for. So this piece here, the one that crosses out, this x plus 2, that's the x value for the whole. So this says I have a whole, it's going to be at negative 2. And the y value is, if I take negative 2 and I plug it into whatever's left, that will give me the y value. So when I plug in negative 2 plus 5 gives me a 3. Negative 2 plus 1 is negative 1. So it'd be 3 over negative 1, which gives me negative 3. So I know there is a whole at negative 2, negative 3. Vertical asymptotes, these are in a denominator. So what's left is x plus 1. So my vertical asymptote will be x equals negative 1. The zeros are also known as roots or x-intercepts. So that's in the numerator. So I have x plus 5, so I know my root is at x equals negative 5. Y-intercept. Let's clear this stuff out of here. So the y-intercept. You find the y-intercept from the back two numbers. So these values. It's because if I plugged in x is 0, all this stuff will go away. So I have 10 over 2, which is 5. So I know the y-intercept is 5. Slant asymptotes, there are none, because for a slant asymptote, the degree upstairs has to be larger than the degree at the bottom, the denominator. So the numerator, it has to be bigger by 1 compared to the denominator. These have the same degree. Therefore, there is no slant asymptote. That will help us with our horizontal asymptote, though. There's 3 cases for horizontal. If the top is bigger degree, then there is no horizontal. If the bottom has a larger degree, then there is a horizontal of the x-axis, which is y equals 0. And in this case, the same degree, the powers of the problem are the same. Therefore, it's a ratio of the lead coefficients, so it would be y equals 1, because there's little 1's in front that we don't see. This is enough information for me to start graphing it. So let's start graphing this. So I have a couple pieces that we have to do here. So what I want to do is I'm going to mark off my vertical asymptote, x equals negative 1. So I cannot touch the vertical asymptote, x equals negative 1. And I will mark off my horizontal, which is y equals 1. All right, so let's just mark these off as 2's so I can see my axes. And they're already marked x and y. So let's mark off, what else do I have here? I have the holes at negative 2, negative 3. 1, 2, 3. So there's a hole right there. And there's a root over here at negative 5. Negative 2, negative 3, negative 4, negative 5. That's solid. So my graph is going to come right down here on the lower, good chunk of it's going to be in the third quadrant. And let's do the top part here. My y-intercept is 5. So I'll mark off 5. And that's the only number I really know in there. So I'm ready to make my graph. And oh, you know what could help us is we could graph this. But now I can tell from this graph, it should look something like this. Without graphing it on the calculator, it's going to look something like this. It's going to head towards the y equals 1, hit this 0, the hole, excuse me, and then head down this way. It's going to lock in here, head up towards the vertical asymptote, and then come down towards our horizontal. And I'm just going to call this thing f of x. Now, I haven't graphed it yet, but I can graph it. So let's check it on the graph. So punch it in. Make sure you use parentheses for the numerator and denominator. So x squared plus 7x over x squared plus 3x plus 2. And we hit graph. Let's see. Yeah, that looks pretty much like it. So let's keep going with this problem. So now it says, create a sign chart for this problem. Well, on my sign chart, what I want to put are my x, whatever hits the x-axis. So on my sign chart, I want to put the vertical, which was -1, vertical asymptote, and I want my root is -5. Now, this is open because it was a vertical asymptote. This was a root. You don't have to make these, these little open and closed circles, but it might help you actually on different parts of the problem. Now, we can look at the graph, even the one we drew. I don't have that on this page anymore, or the one in the calculator. I technically could just plug in numbers into this thing, and like I can plug in a -6 and check the sign. Or I can plug in, but I have the graph, so I can just look at the graph. So if I look over here at -6, I can see it's above. In between -5 and -1, that's where it dips down, so it's negative. And when you get past -1, the curve is above. And if you're not crazy about that, you could go to second table and check out some of these values like we were just saying. So at -6, it's a positive, small, but it's positive, it's 0.2. So in between -5, let's call it -3, -4, it's negative. And anything past gives you positives. So it's the same information. Now this question says, now when we slap the inequality, now it's called a rational inequality. And some people find this harder, but it's based on this number line we just made or the graph that we just did. So we look at now when it says less than 0, this just means where is it negative? Now, since there is no equal sign, I cannot include the -5. So I want this zone right here, but I can't include the -5 because that would make it equal to 0. So it's going to be -5 to -1. Both are open. Let's just clean that up. So -5 to -1. What's the domain? What's the range? All right, well, the domain is going to be a little tricky for this one. So the domain would be from, I could use, it's going to be from here to the hole, then the hole to the asymptote to infinity. So that's my choices. So it's going to be from the left to the hole, this part, hole to the asymptote, and then on the other side of the asymptote, this part over here. And that's horrible looking, but it's just to show us what zones we're talking about. So my domain would be from -infinity to -2. Open on both, because it's a hole. So, and then -2 to -1, which is the asymptote, open on both. And then -1 to infinity, open on both, because infinity is always open and the vertical has to be open. Now the range. The range is the y values. So I'm looking in this direction from here to here. So if I look up, this goes good. So negative infinity to the whole, and then from the whole to the horizontal, and then horizontal up. So we got to write that all out. So it would be from negative infinity to negative 3, because that's the y value at the whole. And then negative 3 to positive 1. That was the whole to the y, y equals 1, the horizontal. And then from 1 to infinity. The end behavior. What's the graph doing at the ends? Now, so this is the general shape, right? Something like this. It's going this way forever, and it's going this way forever, like this. So as we head toward the end here, it wants to approach this y equals 1. And as we go to negative infinity, it also wants to approach y equals 1. That is why that was the horizontal asymptote. These are both the same. Continuity. If this graph is in pieces, or there's holes in it, it is discontinuous. So I could say discontinuous at these places, or I could say continuous. Now there's all different ways to do this. So you could, as long as you can express yourself and make sense, it works. I'm going to say continuous, except at where the hole is. So that's at negative 2, x equals negative 2. And with a vertical, x equals negative 1. Increase or decrease? Increase and decrease. So if I put a ball on this thing and I was going to read it left to right, the ball would roll downhill this way. And if I put the ball up here, it would also roll down. This graph is always decreasing. So you don't write it that way, but that's just what it is. So if I said what's the area, what's the intervals of decrease, it's the same as the domain for this problem. So you could rewrite this whole thing. This all goes down here. So we're going to not write that because we're running out of time, but that's where you would get it from. So hopefully this helps. Use this for your test, review for your test, and have a good night.